This example takes another look at heights of histogram bars, but less directly than before. Instead of giving you the picture of the histogram, the table gives you the numerical description. The height of one of the bars is missing and your job is to fill it in. Let's see what you've got. You've got each of these bins in the first column. The variable is weight being measured in pounds, and the first bin is from 0 pounds to 5 pounds, then 5 pounds to 10 pounds, and so on. And what you have here is not the number or percent in the bin, you have actually the height of the bar. And it's measured in percent per pound. So there's a whole bunch of weights that have been measured, and they've been binned, and someone's drawn a histogram. And you have a histogram of 4 bars, as you can see, and you have the heights of 3 of those bars. And this one, the third one, the height has unaccountably disappeared. You want to see if you can fill it in. You don't have the direct information that you need to just plug into how we've calculated heights before. You have to arrive at it by using the information that you do have. Think about it. Pause the video. And we'll come back after countdown. 3, 2, 1. We're trying to find the height of a histogram bar. How do we find that? It's the percent in the bin, that is the percent in the 10 to 20 bin, divided by the width of the bin. So there's 2 quantities we need. We need the percent and we need the width of the bin. The width we have from 10 pounds to 20 pounds is a width of 10 pounds. 20 minus 10 is 10. Great. So what do we need now? We need the percent in the bin. Do we have it? No, because those other heights aren't percents. They're densities. Percent per pound. So now what? Let's try drawing what we have. We have the numerical scale, and we have this missing bar, and we don't know how tall the bar is, so we actually don't know whether it goes beyond 10, but we just decided that we'd put a sticky tape over that interval up through about 10. So that's somewhere there's a bar of this width, and somewhere it stops at some height, and we have to find that height. And we've just decided that we need the area, and then we can divide by the width of 10 and we'll get the height. The area is the percent in the bar. So how do we find the percents? Well, if we had the percents in the other 3 bars, then we would be in great shape, because the total area of all the bars is 100%. So we could just subtract the total area of the other bars and we'd have the percent that we want, and then we could use that. Do we know the percent in this bar? The height of the bar is 2% per pound, and the width is 5 pounds, 0 to 5. So 5 pounds times 2% per pound, and there's your area. Width times height. Once again, a width of 5 times a height of 3. Next one. This one here has a width of 30. Why is that? It's 50 minus 20. So a width of 30 and a given height of 1. And so we have the total area, that is the total percent in those 3 bars, if we do that calculation. And you work it out, you get 55%. So if 55% of your data is in the other 3 bins, then 45% are in the bin that you want. 100 minus 55. And now you're ready to find your height. You know the percent in the bin is 45%. You know the width of the bin is 10 pounds. And so the height of the bar is 45% divided by 10 pounds, which is 4.5% per pound. And you have completed the histogram.